This conference will now be recorded. This
for
conference will now be recorded.
a variety of roads, parking lots, heavy duty areas. There's anyone on the design side knows there's hundreds of different asphalt mixture designs. These need to be used in the right situations, which can dictate the success of your project for your client. I will turn the mic over to Steve Jackson, who has been in the asphalt industry pretty much his entire life. He started off as a project manager for a company here in St. Louis. He was our QC manager for 10 years and has been overseeing our plant operations for the last 2. So without further ado, Steve, I will turn it over to you.
All right, thank you, Chris. It's kind of strange that we work for the same company and haven't seen each other in a long time, but we see each other every day on these kind of calls. So it is a different kind of times that we're in. So I just want to welcome everybody. We are going to put this on, and of course, I got the obligatory. Here's who I am. That way, you understand. You can say, "Well, that guy knows a lot." Well, we'll see if I can trick you. I am the MAPA vice president this year, so I do appreciate everyone taking the time out of their schedules to attend these emerging leaders conferences and continuing your continuing education in these different times. I've done a lot of stuff across the country. I go around speaking on a lot of things. I've been asked to serve on a lot of different committees. I'm with the National Asphalt Pavement Association. I'm working on some pavement design and balance mix design, something we'll talk about a little bit today. And then I'm on the plant subcommittee. I get to do a lot of peer review of journals, articles for NCAT, things like that. And a lot of people know me because I still help teach the Super Pave Technician course at Rolla. I've been doing that since 1998. So that's where I know a lot of people from the industry. So the challenge here is, as owners, as consultants, as people that have got to build projects, we need to provide a value to the taxpayers and the owners for our pavements. And there's a lot of different options out there and things like that. One of the things that we've been noticing for years is there's kind of a cookie cutter kind of approach to a lot of designs. And through MAPA, we're trying to get more information out to people and trying to help design pavements better. And this is kind of talking a little bit more on the mix design side of it, but I'm not going to go into a lot of details on mix design. We can spend days on that kind of stuff and still just scratch the surface. So just want to kind of high level, kind of some important things. And if anybody has any questions, I'll have my contact information at the end of the presentation, and you can reach out to me. So a lot of the basis for everything comes back to the Asphalt Institute, and I'll share some information about them. But then we also want to look at MoDOT and St. Louis County, and then if consultant, some of the things that happens there as well. So that's kind of where we're going. The Asphalt Institute, they're funded by the oil producers in large part. And so the people that provide the liquid asphalt for our mixes are the ones that financially support the Asphalt Institute. So they just celebrated their 100th anniversary, and part of their mission has always been out there to look into the technical aspects of liquid asphalt and try to promote the use of asphalt, as well as mixed designs and things like that. So they have a vested interest to sell as much asphalt as they can, and they help engineers out to how to design pavements. And they have a lot of good training. I've been to several of them, but that's kind of the background. So if you look into a lot of specifications, there's a line in there that says, refer to the MS2 asphalt mix design guide. And it's in the MoDOT spec book. I believe it's still in the St. Louis County spec book there. It'll have a line that goes back to that. So the MS2, this is the latest edition of it. It's called Asphalt Mix Design Methods. And in this, it actually lays out Marshall mix designs, beam mix designs, which were kind of a California thing, super pave mix designs. It's starting to talk more into performance testing and things like that. So this is kind of the background to it. This is the 7th edition. A lot of the older spec books were referred to a different edition, but this is the current one. But this is kind of the background that people go to start looking at mixed design methods. So if we're going to talk about success, we want to know what is success. So if you're thinking about a pavement, what should it look like? Where should we be going to on mixed designs? How does it perform long term? What are the issues that we typically see? Those kind of things. So that's what we're going to kind of look at here. And normally, if I was doing this in person, I'd kind of poll the room and kind of ask your questions. You know, what do you think success looks like? A little bit harder to do in this format, but I doubt anybody would say this is a successful project. We've got a lot of bonding issues here. The mix is scooting along, tearing, things like that. So that doesn't look like success. Here's another one. This is kind of a moisture-induced issue. This is what happens when you get a bunch of rain and then decide to go pave. That moisture doesn't get out of the aggregates and it starts to come out as you're paving, and it kind of starts stripping your aggregates and foaming your asphalt and things like that. So this was a wet base with wet aggregates and all kinds of problems. And so those are not successful jobs either. Here's another one. I got this one from some folks. They were out looking at this job. It came apart prematurely. And that spot where it's marked core, I have an up close picture of that. And what has happened is after they cut the core, and this is a asphalt lift on top of a concrete lift, and it wasn't bonded very well, so the pavement started slipping along there. And you can see on the right side how the asphalt has slid down the concrete, where the hole for the core is no longer even line up. Here in a second. So what we want to look at here is what does it really look like? So when things are going along well, mix looks good, it's bonded well, everything's going very well, and when you get to that situation, your old buddy Steve says success looks boring, because you're not fighting anything, everything's laying down well, things are going very well. So if there aren't any problems, that's what you're dreaming for out there on a project. So kind of looking at what makes that success, there are a few things that I think are very important. It's got to be stuck. You got to have a good bond there. It's got to be durable, and what we look in there is into the mix designs and aggregates and things like that we're going to use. We want it to look good. If you're paving a parking lot or a road, people are going to look at that and they want to make sure that it performs well, but also looks good. And basically, a lot of times what we want to do is pave this area and then just kind of forget about it and check it back out in 10 years. That's kind of our goals. So that's what I would define as a successful pavement. And of course, on the contractor side, we want to do it for on time and under budget. So stuck, that gets back to your bonding. This is something that I can pull out my files from 2004, and we were talking about bond related issues at MoDOT, MAPA, quarterly meetings. We've been working on this. MoDOT has gone a long way in their requirements, working on this to try to get it lined out where we don't have debonding issues on pavements. What you need to look at there, and if you look at MoDOT spec, a lot of it is the shot rate on the residual. Because one thing that happens is you can have a tack coat, but then if you cut it with water, it cuts that residual asphalt that's in there. So after it breaks and all that, you want to have a good residual bonding agent there that holds your pavement. Can you cut it in the field? Some places they do that. There's a maximum that you can cut it in the field. A lot of times though, you kind of want it coming in to your job that's already been cut, or it's at the optimal there. Cure time, if you're laying a pavement like this week, temperatures have dropped down a little bit. It's going to take longer for it to cure. If you get out there in July and August and the sun beating down, it's 100 degrees out, that cure time is going to be a lot quicker. So you need to let it cure before we get traffic on it, things like that. And I think one of the biggest things we fight is tracking, where we actually do a good job shooting the tack, but then we get trucks on it and pull it off. And then it ends up being tracked back to the stop bars of every intersection on every road that truck stops at going back to the plant. So here's kind of a picture of that. This is a concrete pavement they're trying to overlay with an asphalt layer, and they went out and shot it, and then we got traffic on it, and it's tracking it back off the job. So when we get to that point and we go and lay mix over this, where that tack has been pulled off of the concrete, after traffic gets on it, we're going to start looking at issues there in those wheel paths. So I would say this is not a good candidate for being stuck or well bonded. So this is a spray paver setup, and a spray paver is very good about doing bonding. It actually sprays a polymer modified emulsion tack in front of the mix, so there's no traffic on it. It's fast breaking, sets up very quickly, and does very good job of providing a well bonded pavement. You typically see these with ultra thin bonded asphalt wearing courses, U-balls or surfaces. So they use them there. MoDOT has been using this a lot with regular paving now, trying to bond over concrete. So putting a super paved mix over a concrete pavement, had a lot of success on that. We did a project in 2012 on Route 30 in Jefferson County. I've been driving it every day here recently, and there's still a few cracks in it at the beginning where we had our temperatures too high, but we're looking at 8 seasons later and it's still performing well. So that's kind of a bonded using a spray paver. The other part of this is what we're getting into is trackless tacks. There is success stories with trackless tacks, and there's failures with it. And a lot of it comes down to whether when you're laying down the mix and shooting the trackless tack, there's various competing products out there. And the specification for each one of those products is very different. And that kind of leads to performance variations as well. So if you're going to use a trackless tack, it's wise to kind of talk to people that have been using them and finding out what's been working and what hasn't, and get as much information as you can. But our regular way of doing stuff still works as well. We've tried some things with MoDOT by wetting the surface and then shooting the tack, and that tends to let the tack spread out more uniformly across the road. So that was another option that we've used in the past with to make sure we got a good bond. But that bonding is very important. So when you get to looking at pavements, and with our mixed designs, we're not really seeing a lot of rutting anymore. We're using recycled materials. That helps it fight rutting. Our super paved mixed designs were designed to resist rutting. The thing that we've been seeing a lot more here lately is cracking, but it goes back to a lot of the issues that we see just come back to debonding. If we don't have a good tack, and like that picture showed where the dump truck was taking it out of the wheel pass, what you'll see then is after you get traffic on that and you get a couple summers on it, you'll start seeing like a chevron cracking in those wheel paths where the mix in the wheel path isn't stuck as well, and then the other mix around it is, and it'll start sliding, and you'll start seeing cracks there in your wheel path, which is a form of cracking, but it's kind of debonding, letting it slip. So those debonding and cracking are probably the biggest issues that we see, and a lot of them are related then too. So that's why I spent a little time on tack coats, because that is a very important part. We can get into the mixed design part of it, but we got to make sure our pavements are stuck. So I just kind of, for this group today, I want to kind of show a few different things here on mixed designs and just kind of the similarities between them. So on the left side is the MoDOT mixed designs that we would see kind of in their 401 and 402 sections of their spec book. So they're what we commonly called a bit base. That's the base mix that we put down everywhere. Their next series is it's called bituminous pavements. So it's BP1, BP2, and BP3. BP1 is going to have the largest aggregate in there. Then the BP2 will have smaller aggregate, and then BP3 will have the finest aggregate out of those series. Typically, a BP3 is like 100% passing 3/8 roughly, and then the BP2 will typically have like a 1/2 inch, and the BP1 can have up to 3/4 inch. So those kind of pavements are the typical ones we see from MoDOT. And then they also, in their 402 section, they have a surface leveling mix, which is just to go out and kind of fill in the ruts in a road before you overlay it, or try to do a thin lift over a road, usually in lower traffic areas. So that'd be in their 402 section. St. Louis County, their common mixes are X mix, which is kind of similar to the bit base from MoDOT. The C mix is similar to the BP1, and the D mix is similar to BP2. They're going to have similar gradation requirements, not exact things like that, but overall, they're similar mixes. And I'll talk about some of the differences here. So the St. Louis County mixes, they are designing specifically for a high traffic area. So typically they're going to require a higher compactive effort on their mix designs. They are going to try to get a mix that's going to stand up to their, high traffic, turning, slow moving traffic, things like that. So they'll typically, their spec calls for a 50 blow Marshall, or the option for a 40 gyration gyratory compacted mix. Those kind of mixes are not what you're going to see on their major routes. These are going to be on some of their collector routes, subdivision, things like that. This will be for your County C, County D, County X mixes. MoDOT, when we're looking at those kind of mixes, the BP1s, bit-based, those kind of things, they're going to be a 35 below Marshall or a 35 gyration mix. So similar, close to each other, things like that. On the mix design side, if I've got to design a St. Louis County mix, I'll probably start with that and then get that lined out, and then we'll kind of take a look at it then and see if it if we recompact it, if it'll meet the MoDOT requirements. And a lot of times we can design a St. Louis County mix and then kind of back off a little bit, and we'll have our MoDOT mix, the equivalent mix, designed as well. So just have to tweak it a little bit, but that's typically how we do things. Same thing with super paved mixes. We can design a super paved mix for St. Louis County specs, and it'll typically fall right in with MoDOT specs. So that's one way that we try to minimize the amount of mix designs that we have to do every year. So kind of the differences here that we're looking at, MoDOT designs their mixes now for their 401 section at 3.5% air voids. So they've lowered that. It used to be 3.5 to 4.5 a few years ago. They changed it to design them at 3.5% air voids. St. Louis County uses 4% air voids. They have a little bit, they have a chart in there too on that impacts this VMA requirement. So you can design your air voids a little bit different based on back to that Asphalt Institute MS2 guide. But this is kind of, if you design a St. Louis County mix at 4% air voids, your VMA, which is your voids in your mineral aggregate, that's kind of your aggregate skeleton of your mix. And then that aggregate skeleton set, and then you have to kind of fill in that skeleton with asphalt cement to get your air voids. So the VMA, you can kind of look at it, the bit base and the X mix, they have the same VMA requirements as minimums. As you kind of go down in rock size, your VMA is going to go up. And if you think about that, if you have a rock, if you have one single rock and you break it in half, well, now you've created more surface area that you have to coat with oil. So if you keep breaking that rock down, you create more surface area there. You're going to get kind of a angular fraction on there, you hope, a lot of times, and you're creating more surface area. So the VMA calculation takes into account the amount of oil that's in the mix. So more surface area is going to require more oil to coat those surfaces. So your VMA requirement is going to go up as well. So as you can see, that as the smaller the rock size becomes, the more VMA you're required to have in your mix. So you build that aggregate skeleton, you fill it back in with oil. The difference between your VMA and your air voids is the amount of oil that you put in there. I'm not saying you're going to put 10% oil in, but when you start calculating those, the air voids in your aggregate, and then that air voids at top is your air voids in your mix. That's the difference there. There's a third requirement called voids filled, and typically around 3/4 of your air voids are going to be filled. I'm sorry, your VMA is going to be filled with asphalt. So that's the other requirement. But you can see these, they're different design technologies, a little bit different specification. This is going back to that MS2, these kind of requirements on this screen. So very similar. So then what happens is I pulled a mix design that was out of the same quarry around St. Louis area here, and kind of looked at it. So if you start looking at it, the big one there is the 3/8 inch. I had 36% 3/8 aggregate in the St. Louis County mix and had 19 on the MoDOT mix. And that's a big one. And if you go down a little bit, the St. Louis County mix didn't have screenings in it. We had to pull those out to make other things work. And then the big one is the wrap. And I want to discuss the wrap there a little bit. St. Louis County kind of has a a maximum that you can use on wrap. A MoDOT by specification, if you could make it work out, you could run 100% wrap mix. It's just that it doesn't really work out that way, and having the availability of wrap becomes an issue as well. So these mixes were both designed in the same year, according to the current specifications of that year. This is not a current mix design that we're running with these, because I figured there'd be people that I bid against on stuff that would be watching this. But this is kind of, even though we go through all these different specifications, you can see that a 35 blow Marshall mix design for MoDOT and a 40 gyration mix for St. Louis County, when you start looking at your final aggregate percentages and your total binder, they're really not that much different. I've seen other ones, like I said, for our super paved mixes, we've actually just taken St. Louis County's mix designs and submitted them to MoDOT. We've seen these County C mixes and BP1 mixes be very similar as well. A lot of it comes down to the amount of wrap in there. So through all this kind of stuff, you kind of get to the same point on your mixes. So one of the things that does change then is, how do we check in the field how our mixes are going to perform? And once you decide on what kind of mix that you want to run, then you're going to have to do quality control and things like that in the field. So when we're looking at inspection, this is for non-super paved mixes. MoDOT will take asphalt binder samples and they'll send them back to their lab in Jefferson City, and they'll just kind of verify that the binder that they're getting meets the criteria. In the field, say for BP1 and those kind of mixes, we're going to look at the gradation, deleterious content in your aggregates. You're going to run a asphalt content through a ignition oven or a nuclear gauge, and then you're also going to check density. Same kind of things that we're going to be looking at for St. Louis County in those kind of mixes. St. Louis County does a field verification of their mix designs that MoDOT doesn't. So they'll actually come out, take samples, take them back to their lab and compact them and make sure the air voids and everything are close. And so that's another step that they do as far as inspection on their projects. Now for super pave, we're going back. We want to check the air voids. We want to check that voids in the mineral aggregate, the asphalt binder content, and the density. Those are what's known in on MoDOT contract as the pay factors. So we get paid on how consistently we meet the targets on those 4 items. The way you do this is you take a sample from the road, you bring it back to your lab, and you'll make gyratory pucks up to check your air voids. You'll take a sample, it's called a RICE test, or a maximum theoretical specific gravity, or GMM, and that will help you. It's where you take the sample and you break all the rocks apart with the oil on them and put them in the water and vacuum them and come up with your maximum theoretical specific gravity to compare your pucks to. Then the binder content, same thing as we did on the other one. We take a sample, we burn it off, we use a nuke gauge or to determine that binder content. And then our density is typically a core cut from the roadway compared back to that maximum theoretical specific gravity. So those are our pay factors. Each one of them is about 25% on the pay for MoDOT contracts. We also looking at other things like smoothness. A lot of MoDOT contracts have a percent ride improvement, or if it's multiple lifts, there's different specifications on those. We do that with the International Roughness Index, the IRI. So we'll run the pavements after we're done paving a section to make sure they're smooth. We also use a stripping resistance, which is where the oil strips off the aggregate. So that's when your pavement starts to come apart. So we use the tensile strength ratio on that. And new things that we're getting into now is intelligent compaction, which is actually a GPS mounted system on the rollers. And it will show the roller operator when they make the optimum number of passes on each section of the road. So a roller operator typically has to sit there and pick a spot on the road, and they're going to say, hey, I need to make 5 passes on this, across the whole map, and then move forward. This intelligent compaction gives them a screen to look at, and it will actually make sure that they get every part of the mat compacted consistently. Infrared scanning shows temperature variance in the mix. So there's limits on that. This is actual an infrared bar that mounts to the back of the paver, and it will show you if you're getting consistent temperatures in your mat. So this is things that MoDOT's using, other people are adopting it, but I think the intelligent compaction and infrared scanning, they're going to start speccing that out on most of their jobs, especially the interstate work, things like that coming out. So that is another tool that they are using. So one of the things though that we do here is we do all this testing, and it comes down to, does any of those items actually guarantee your success? And there's a movement now onto testing your mix based on its performance properties and not just a set of lab criteria. So this is the first edition. This is back with the Asphalt Institute. It's the Super Pave, and it says level 1 mix design. This was the first books out there on how to do Super Pave mix designs with a gyratory compactor. Started talking about performance graded binders and things like that. So first edition of this, probably 1996, 97. Chapter 7 in there was called Level 2 and Level 3 Mix Design. And then they had a chart in there. And they mentioned all these kind of sweep tests and different things. They were looking at fatigue cracking, low temperature cracking, permanent deformation, which is rutting. So there was a level 2, and it had some guidelines on tests to run on that. And then there was a level 3 that went up even beyond that. And from the beginning, that was supposed to be part of the Super Pave specification. What turns out is to run those tests, you're talking about equipment that was $750,000 to run one of these tests. The Asphalt Institute had that equipment. They still have it in their labs. They can perform this. The technologies is improved and things like that. The Federal Highway Administration has got some of these fancy equipment. They have a mobile lab that they can come out and do some of this testing. So there's still a movement out there to do more testing on just beyond your mix design criteria. So with that, as we moved on, by the 3rd edition of this SP2 design guide here, they had taken that chapter 7 out because of the expense with implementing that level 2 and level 3. So it kind of got taken away. We went back to just doing our air voids, VMA, AC content and density, and we've pretty much been doing that. I think MoDOT's first Super Pave job was in 1996, and we're still kind of, that's what we're checking in the field. So last few years, we've kind of started looking at balanced mix design. And a balanced mix design will start with a Super Pave mix design, and you're going to adjust things where you're looking at field performance, your rutting resistant, your cracking resistance. So with that, what we'll do is look at that aggregate skeleton, your VMA, take a look in those aggregates that go into it, make sure we got durable aggregates. The other thing that came part of that was the polymer modified oils. So in Missouri, we actually have 2 different kind of grading systems. The performance graded PG system. So that'll be spec'd out as a PG 70-22 or something similar. And then we have the massacre grading system, which is multiple stress creep recovery. And it'll be spec'd out something like a 64H-22. We can get these in the Illinois over at Phillips 66 provides these into our market. MoDOT will accept either one of these, and St. Louis County will also accept them. The massacre system is newer. The difference is you're performance graded. You ran tests at different temperatures and had the same criteria. With the massacre grading system, they keep the temperature constant, but they change the values that they want to see on these binder tests. So that's a different system, way of looking at things. The massacre system's used a lot in Missouri. The other thing we've done is looked at recycled asphalt pavements. They do stiffen up a mix, so to resist rutting. And then cracking resistance, we look at the asphalt binder content. We're looking for mixes that compact easily, because if we can get field density up there around 96%, we're going to keep the water and the air out of our mixes. They're going to be more durable. We need to make make sure we have durable aggregates, and we also have to make sure we got bases underneath all these pavements that drain. So the balance mix design, we kind of do the same thing that we do with super paved mixes. We pull mix from the road, we run some tests, but we actually have this year a performance testing JSP from MoDOT. It's on their website. And what you do then is with that loose mix you collect, you'll make up samples for the Hamburg wheel tracking device. And this is looking at your rutting potential of your mixes. So if we put them in there and run that steel wheel back and forth across it 5,000, 10,000, 20,000 times, we want to make sure the pavement doesn't rut. And then I think most people are leaning towards what they call the ideal CT, which is the ideal cracking test, which makes up gyratory pucks. And then we load them at a rate, and we start looking at the fatigue cracking or part of this design here. So we want something that doesn't rut under the Hamburg, and we want to make sure it's still flexible enough with the ideal CT. So looking at this super pave, it's good. It's good for roads. You typically are not going to need a super pave on parking lots under normal traffic loads. If you get into shipping areas or high truck traffic, that may be something that you want to look at. But those are designed for very high traffic levels. The other part of this is who's doing your testing and what kind of testing are you going to require. There's typical tests that we do with MoDOT mixes, and those are pretty straightforward and common that your contractors are going to know how to do. And that's one thing I want to talk about too is, the contractors, we run these tests every single day. This is how we do our mix designs. We submit them to MoDOT, we submit them to St. Louis County, different agencies. We do quality control testing day in, day out. If you ever have questions, reach out to your contractors. They're the lab folks on these contractors have got a lot of experience. I know Fred Weber's got Dave Marshall up there, Andy LaPlante at Interstate Testing. They've been doing this a long time. So there's a lot of expertise out there. Reach out to them. Polymer modified asphalt, it's good. You're just going to have to decide if it's worth the extra money to spec that out in your projects. Typically for higher traffic levels, that's what you're looking for. And I wanted to spend a little time on balanced mix design because every conference that you go to these days is talking about it. It's being implemented at the state levels in a lot of different states across the country. And When you see that kind of stuff, then it tends to kind of get out there in the vernacular, and people start talking about it. But same thing with super pave on a balanced mix design. Doesn't mean you need to throw a specification out there and include that. But the other thing too is to consider is testing for a BP1 or a county C mix has a certain set of tests, and you really can't just pull super pave test and throw them at those kind of mixes, and you can't really take balanced mix design specifications and try to run them on every pavement out there as well. So with that, I would be open to any questions, and here's my contact information if anybody would like to reach out to me.
I'd like to say thank you, Steve. And Brandon, I think you can see the comment section. I don't know if we have anything in there that
I've got it here, Chris. Actually, yeah, and there's no questions or comments in the chat that I could see. So the lines are unmuted. If you wanted to unmute your own line, if anybody has any direct questions for Steve or any of us at this time, we're open for questions if anybody's got any.
I would like to point out just on parking lots. I mean, I think there's a number of people out there that have varying ways to put down tack coat, but for everyone doing parking lots, keep in mind, if you are doing an overlay, that tack coat is just as important on a highway. You really have more cars coming in and out of those parking lots, turning, twisting their tires. That mix on the surface is more susceptible to tear or to move if you're not putting tack coats down. So, I mean, Steve spent a lot of time discussing that, and I think it's a very valid point to make. And there's a lot of guys on this call that make trackless tacks and basically high performance tacks that set up quickly. If you're not using them, it may be something to look into, where you can put your tack down and get on it rather quickly.
I would also like to add into, as Steve mentioned, the contractors in the area that are a great resource for anybody that may need some additional help or guidance on this. And I just wanted to make sure everybody was aware that, MAPA is here for that as well. So if you guys are working on speccing something, or took some stuff from this call here today, and you want to put a little bit more care into your spec in the future, we are certainly here to help you with that and make sure that we can get you some additional information to make sure that you are choosing the best mix that will perform for your owner. So we're here to help with that as well.
I will say here again, thank you everyone for being on the call. If you or anyone in your organization is interested in joining either the MAPA organization or the MAPA Emerging Leaders group, please reach out to Dale, Rick, or Brandon. The next webinar is going to be April 30th on why parking lots matter. Someone from the Kansas City group will be hosting that. And then also on June 3rd, the emerging leaders are going to put on a webinar of the proper bid process, which a lot of parking lot contractors or contractors doing private work, the owners that are speccing those usually do not know what they're speccing. And we're going to try and create a template for you guys to use for those owners, so they know what the differentiators are in each vendor's bid. A lot of times they're not getting apples to apples bids. So we look for that to be a very big webinar as well. So thank you guys again.
Thanks, guys. Have a good day, everyone.
Thank you.